Hello everyone, welcome to my channel. Today we will be looking at understanding your data part 2. This is a continuation of a series on the topic understanding your data. Some weeks ago we released a video on the understanding your data part 1, in which we discussed about how we can understand our data and we can play with our data, because we explained that what really determines our estimation parameters is how well we can understand our data. And in the video, we discussed about binary data. We discussed about interval data, categorical data, and also continuous data. So if you've not watched the part 1 of this series, I'll encourage us to go and watch it to have a better understanding of this part 2. So today we will be looking at understanding your data part 2, and we are considering binary logistic regressions on minitab. As we all know, minitab is a software that is user-friendly, easy to use, and so on and so forth. So we are considering binary logistic regressions. Why are we considering binary logistic regressions? Like I said before, what really determines your estimation parameters is your dependent variables, that is your response variables. So if you are working with a response variables that has two options, such as a yes or no, if you're also working with a response variables that has to do with passing a course or failing a course, or you're working with a response variable that has the option of dead or alive. So in that case, you need to work and you want to estimate or predict the variables. You need to work on binary logistic regressions. So, and that is why today we are considering binary logistic regression, because our data set has a response variables of yes and no, the risk of having a coronary heart disease. So what are the learning outcomes? So these are the first steps you need to understand before you can analyze your data set, your binary logistic regressions or minitab. The first one is you need to determine whether the association between the response and the term is statistically significant. The step 2 is you need to understand the effect of the predictors. And the step 3 is you need to determine how well the model fits your data. While the step 4 is you need to determine whether the model does not fit the data. So these are the 4 steps you need to take into considerations when analyzing binary logistic regressions on the minitab. So the first one is determine whether the association between the response and the term is statistically significant. So one of the ways to check if is to determine the association between the response variables and the term is to check for the p-value. So the p-value, if the p-value is less than or equal to your level of significance, which might be 1%, 5%, or 10%, then your model is significant. But if your p-value is greater than your level of significance, which might be 1%, 5%, or 10%, as the case may be, then your model is not significant. Then another thing you need to do, you need to check for the p-value of the coefficient. It is the same interpretation with the p-value of the model. So if the p-value of your coefficient is less than your level of significance, then your coefficient is statistically significant. And the third one you need to check, if you want to determine whether the association between the response and the term is statistically significant, is to check for the 3S. The 3S is the significance of your coefficient, the size of your coefficient, and the sign of your coefficient. You can check your significance through the p-value of the coefficient, and you also check the value, the size. The size is the magnitude, how large or how small is the value of your coefficient, and also the sign is the positive, can be positive or can be negative. So you need to check for the 3S of your coefficient. So if you have a positive coefficient, this therefore implies that a percentage increase in your predictor will lead to a percentage increase in your response variables. But if your sign is negative, it therefore implies that a percentage increase in your predictor will lead to a decrease in your response variables. So these are the things you need to consider when you want to determine whether there is an association between the response variables and the term and if most especially if you want to know if they are statistically significant. So the second one is you need to understand the effects of the predictors. So one of the ways to check for the effects of the predictors is to check for the odd ratios. The odd ratios can be less than 1 and odd ratios can be greater than 1. So if the odd ratios is greater than 1, and this therefore implies that it is more likely for the event to occur. It is more likely for your response variables to occur. But if your odd ratios is less than 1, it is less likely that the event or your response variables will occur. So the interpretation for the odd ratios for the continuous predictors is different from the odd ratios for categorical predictors. So if you're working with categorical predictors, you need to interpret the odd ratios across the levels of your predictions, of your variables. For example, if you're working with a response variable such as yes and no, so you need to interpret your odd ratios across the yes and no. So I will show you some examples when we're working with the software. So the third step is you need to determine how well the model fits your data. And there are 3 estimation parameters to check that. You have the deviance R square, you have the deviance R square adjusted, you also have the archaic information criteria. So the interpretation for deviance R square and deviance R adjusted is the same. The higher the value for deviance R square and the deviance R square adjusted, the better the model. Whereas the archaic information is different. The smaller the value, the better the model. And the last one is you need to determine whether the model does not fit the data. And there are also 3 estimation parameters that enable us to determine whether the model does not fit the data. The first one is the deviance, the second one is the Pearson, the third one is osmolemon show. So we have the same interpretation for these 3 estimation parameters. And they have, if the p-value is greater than your level of significance, this therefore implies that the model is statistically significant, that the model is fit to explain the changes or the variation in your dependent variables. So the next thing is for us to show some hypothetical example on the minitab. So these are data sets in Excel sheet. And then the first thing you need to do is to do a whole lot of data cleaning, data transformation, and stuff like that. So if you want videos on how to clean your data, on how to clean your data set, you can check my my YouTube channel. You will see different videos I've made on how to clean your data set. So, but we will skip that in this section. So you need to the first thing to do is to insert. You need to create a table for our data set, and you click on insert and click on OK. So this is a table for our data set, and click on, and you have to press Ctrl S to save your data. So you can go to your software now. This is the minitab software. This is the interface. Under here, we have our output results. Under here, we have a spreadsheet, a worksheet, where we can upload our data set. So if you want to upload your data set on minitab, it's either you press Ctrl O or you click on File. When you click on File, you click on Open, and you try to look for where you save your data set. I save mine on the desktop, and you look for a data set, you click on it and press Open. So automatically you have the preview of your data set, and also click on OK. So these are the data set that we are working with. The first one is male. The male is a binary or a categorical variables. The age is a continuous variables. Education is a categorical variables. Are you smoking currently? Is a current smoker is also a categorical variables. Is how many cigarettes you smoke per day is a continuous variables, also known as a count variables. You have blood pressure medication. Do you take any medications for your blood pressure? It's also a nominal variables, categorical variables. Do you have any prevalent small stroke? It's also a categorical variables. Do you have any prevalent hypertension? It's also a categorical variable. So you need to understand the kind of data you're working with. So you also have diabetes. Do you have any diabetes? It's also a categorical variables. So total cholesterol level, systolic blood pressure, diastolic blood pressure, body mass index, heart rate, glucose level, and then glucose level. They are all continuous variables. However, we're working with this dependent variable is the risk of having a coronary heart disease. This is the response variables. It has two options, and that is why we are working on binary logistic regressions, which is zeros, yes or no, which is coded into zeros and one. So this is the predictor. So the next thing for you to do is to go to start, click on regression, and after regression, you come down to binary logistic regressions and click on fit binary logistic model. The next thing for you to do is to click on response. What is your response variables? You click on the risk of coronary heart disease. Click on select, automatically it goes into the response. You can check the responses event, which is 0 and 1. That's correct. Then, so for the purpose of this video, we will be considering true continuous predictors because we have so many in this data set. We have so many continuous predictors and also so many categorical predictors. So we will be looking at two continuous predictors and also two categorical predictors. So what are the continuous predictors we have in our data set? We have cigarette per day. So you click on cigarette per day, you click on select, automatically it goes into the box. We also have total, let's do glucose level. We also click on select. So categorical variables, we have male. So categorical variables, we click on select. We also have a stroke, prevalent stroke. It's also a categorical variables. Click on select. So you go to you can click on the results. So under the results, you have different options: the method, the response information. So if you need that, you can click that. The analysis of variance, the model summary, the coefficient, the odd ratios. Then under you have the separate equation for each of the categorical predictors. You can put the single equation and goodness fit of test, fitness, fit diagnostics, so on and so forth. So whatever case, whatever estimation parameters that you need or information that you need to check on the result and click on OK. So click on OK. So your result comes into this output in this format. So you can drag this down and drag this down. So this is the method, link function, logistic regressions, categorical predictor coding. The row used, you have the 3,852, row unused 386. So this is the response information. Like I said before, our response variable is the risk of having a coronary heart disease, which is coded into 1 and 0. So the count for 1, which is yes, is 596. What is 0 is 3256, and the total is 3,852. So this is the regression equations. So this is the logistic regression equations. We have the constant, we have the cigarette value, the coefficient for the cigarette per day, and the coefficient for the glucose level. We also have the coefficient for male, coefficient for the prevalence stroke, the categorical variables. So these are the coefficients. So the first thing we need to do is we need to check for the significance of the coefficient. The constant is significant at 1%. This is a constant. The coefficient is negative. The constant of this equation is significant at 1% and 5% and also at 10%. So the cigarette per day, which is also a continuous variables, has a 0.00774 coefficient. This coefficient is also positive because there is no negative sign in front of it, and which is also significant at 5 and 10%. We also have the glucose level. The glucose level, which has a coefficient of 0.01025, is also positive and it's also significant at 1%, 5%, and 10%. So the coefficient for male, which is one of the responses of the options under male, it has the coefficient of 0.4424, and it's also positive and it's also significant. It is the same thing for the prevalent smoke, 1.581, and also significant at 1%, 5%, and 10%. So the next thing is you need to interpret the odd ratios. The odd ratios like I said in the previous slides, the odd ratio, the interpretation for the odd ratios for continuous predictors is different from the interpretation of the odd ratios for categorical predictors. However, they have the same decision rule. So if the odd ratio is greater than 1, there is more likely that the event will occur or your response variables will happen. But if it's greater, if it's less than 1, there is less likely that the event will occur. So the odd ratio for cigarette per day and glucose level is greater than 1. And this therefore implies that the odds, so the interpretation for these variables is that the odds that cigarette per day and glucose level will cause a patient to have a risk of heart disease is 1%. Is 1%. The risk of having is more likely that cigarette per day and glucose level will cause a patient to have a coronary heart disease by 1%. And then the interpretation for the odd ratios for categorical variables, and this is across level, the interpretation, the odd ratio is also greater than 1, which is 1.5564, and the odd ratios for the prevalence stroke is 4.8594, is also greater than 1. So the interpretation for the male, this implies that the odd ratio that being a male will have a risk of having a coronary heart disease is 1.5%, is greater than not being a male, which is greater than being a female. While the odd ratio for smoking, for stroke, having a prevalent stroke to have a risk of coronary heart disease is more likely that someone that has a stroke will have prevalent stroke, we have a risk of having a coronary heart disease than those that does not have a stroke. So as you can see from this interpretation, you will notice that we interpret this odd ratio based on the level of the responses in each of the variables. So the responses of the male is being a male will have a risk of having a coronary heart disease, or not being a male, we have a risk of having a coronary heart disease. So for this odd ratio, so the interpretation therefore implies that since the odd ratio is greater than 1, so being a male is more likely that being a male will have a risk of having a coronary heart disease than not being a male. So also the same thing for prevalent stroke. Having a prevalent stroke, there is more likely that having a prevalent stroke will have a risk of coronary heart disease than not having a prevalent stroke. So that's just how to interpret the odd ratios for categorical variables. We also have the model summary, the deviance R square, the deviance R adjusted, and the AIC. As you can see from this model, the deviance R square is very, very small, and also the deviance R square adjusted is also very small. And this is because the model, the predictors, we only considered 4 predictors out of so many predictors you have in the data set. So as we increase the predictors, then the R square will tend to increase. And like I said before in the previous slide, the AIC, the smaller the AIC, the better the model. So this model, we need to include other predictors that can influence the risk of having a coronary heart disease than just cigarette and glucose and being a male or having a stroke. So there are other factors that can cause the risk of having a coronary heart disease. So the goodness of fit test, like I said, we have the deviance, the Pearson, and then Osborne length show. So the interpretation of this goodness of fit test is that the greater your p-value, which is if your p-value is greater than your level of significance, which might be 1%, 5%, or 10%, as the case may be, then your model is fit. Then this implies that your data is enough to explain your model. So this is just a summary of how we can run a binary logistic regressions on the minitab. So if what really determines your estimation parameters, like I said before, is your dependent variables. So if you're working with a dependent variable that has two options, you want to predict the outcome of your, and you're working a predictive analysis, then you need to consider binary logistic regressions. If your dependent variable has an ordered categorical variables, then you need to consider ordinal logistic regressions. So if you have a dependent variable that has to do with the number of an event, the number of children, the number of accidents, and so on and so forth, then you have to consider count regressions, also known as the Poisson regression. So what really determines your estimation parameters? It's your data. And that is why we are considering a series of sessions on understanding your data. You need to understand your data. You need to understand if your data is categorical variables, or you need to understand if your data is a continuous variables. So guys, watch out for my next videos. We will be considering ordinal logistic regressions, because we are working with an ordered and dependent variables. And then we'll also be considering a Poisson regression, because we are also considering a number of an event as our dependent variables. Thank you for watching. You can subscribe to my YouTube channel so that you get the notifications once I upload another video. Thank you and bye.